Hi friends, welcome back to your channel. In this channel, we try to solve the previous year's physics question papers of Neet undergraduate exam. This is also helpful for those appearing for JEE mains. This is solved in a very student-friendly manner so that you can understand and apply the concepts. We have tried to include all different kinds of questions appearing in exams so that your preparation is complete. If you like the content, we urge you to like the videos. This will motivate us to create more content for you and help you in your exam preparation. We also urge you to subscribe to the channel so that you are immediately informed of any content added to the channel. If you have any doubts, then please feel free to add them in the comment section. We will revert to you at the earliest possible. So without much ado, let's get started. So in the previous video, we had shared 10 problems, 12 problems for rotational motion. In this video, we'll be solving those problems. In this question, it is given that a particle having mass of 6 kgs, right? So this is the mass given to us, 6 kgs. Okay, it is moving with a uniform speed of, speed is equal to v is equal to 5 root 2. Okay, and what is the direction? The direction is like this, right? It is moving along this line. Okay, right? In the yz plane, along the line z is equal to y plus 5. So this is the equation of the line z is equal to y plus 5. We need to find what is the angular momentum. What is the angular momentum of the particle about the origin? Okay, now where is the origin here? The origin is here. Okay, so basically there is a particle which is moving along this line. This is a line given, right? This is a line given to us. Okay, and we need to find that what is the angular momentum of the particle about the origin. So what is the formula for angular momentum? Angular momentum, okay, is equal to linear momentum. I'll just put it in short, LINMOM, into the distance, okay, into the distance from the point from which we are computing. Okay, so we are trying to compute from the origin. So this is the distance we are talking of, right? Imagine that this is R. Okay, so I just try to put out here, so to make it more clear, this is the O origin. Okay, this is the Z axis, right? This is Z axis here, which you can see here, and this is a line going like this, right? So line Z is equal to y plus 5. Okay, so we need to find that how much is this distance. So how do you find this distance? So to find this distance, I think we need to understand some concepts in coordinate geometry. Okay, so one moment. So I'm just trying to explain you in concept in coordinate geometry here how to compute this. So imagine that we have a let's talk with a very simple thing, right? Imagine that we have the equation y is equal to mx plus c. Okay, simple thing, right? So this is the y-axis. Okay, this is the y-axis here, and this is the z-axis, right? And imagine that this is y is equal to mx plus c. Okay, so we have been knowing that this is equal to tan theta. Okay, if this is y is equal to mx plus c, if this is the equation of the line and this is y-axis and if this is the z-axis, okay, then we have been knowing that y is then this is the angle with the x-axis. Oh, sorry, I'm extremely sorry. This is the x-axis. Sorry. Yeah, if this is x-axis, then y is equal to mx plus c. Imagine if someone gives you an equation like this, right? So 3x, I'm giving an example to you. 3x plus 4y is equal to 12, and you are expected to find out that what is the angle this line makes with either of x-axis or y-axis, right? So how do you find it? So what you do is that take the coefficient take the coefficient in the denominator. Okay, so I'll take the coefficient denominator, so this becomes 3x divided by 12 plus here also 4y divided by 12. So in this has to be in such a manner so that x and y are on the same side and the coefficient is on the right side. Okay, it doesn't matter is a negative or a positive coefficient, but it has to be on the right side. Okay, so right side has to be reduced to 1. So this becomes 3x by 12 plus 4y by 12 is equal to 1. So now this becomes x by 4 plus y by 3 is equal to 1. Okay, right? So now what does it mean then? So imagine that we have x-axis and a y-axis here. Okay, so imagine that this is the x-axis and this is the y-axis. X is equal to 4. The numerator is x here, the denominator is 4. It means that the line has an intercept of 4 here. Okay, the line has an intercept of 4. So the x-intercept is 4 here. Okay, and the y-intercept is 3. Okay, the y-intercept is 3. It means the line is passing like this. Okay, where both are positive here. Okay, x by 4 plus y by 3 is equal to this thing, right? So what is the angle which it makes then? The angle which is being made is this, right? This the angle it makes is the x-axis. Okay, and this is the angle it makes is the y-axis, right? So if I'm saying theta y, and if this is saying theta x, okay, so this is what it is, right? And this is 90 degrees here. Okay, so this is how you find it, right? And we can also do it like this, right? So if I have to find that what is the angle which is there between this line, this is the line, right? This is the line which we saw. This is the line. Okay, this is the line here, which we said 3x plus 4y is equal to 12. Okay, this is the line here. This line makes an angle of theta x, right? So it means if I just bring it to the form of y is equal to mx plus c, this form, it means that, so this will become 4y is equal to minus 3x plus 12. Okay, so y is equal to minus 3 by 4x plus 12, right? So this becomes a slope. So this becomes a tan theta x. Okay, and similarly for y, right, we have to similarly bring the y on the right side and x on the left side. So it becomes 3x is equal to, if I'm just trying to bring this y to the right side, correct, is equal to minus 4y plus 12. It means x is equal to minus 4y, or rather minus 4 by 3x. Okay, actually this should have been, okay, plus 12 by 3. Okay, so now here this is the tan theta y. Okay, so why is this negative here? It is negative because this is the angle which should be there, right? This is the angle which should be theta x. Okay, and this is negative because this is the angle which is theta y, which is the negative angle. Okay, so this is how you find it, right? Now let's go back to the original problem here. The original problem here in this case, right? In this case, the equation is given z is equal to y plus 5. Now I need to find the angle between this line with this line. This is a line here, right? I need to find angle between this and z axis, right? This is z axis here, right? So what will I do here? So I'll reduce this equation to y is equal to z minus 5. Okay, so z minus 5, in that case, what is the coefficient here? This becomes 1. Okay, it means this is a theta z, tan theta z. Okay, it means, so, and tan theta z is equal to 1. So it means theta has to be equal to, because you know tan theta, so tan theta z is equal to 1. It means theta z is equal to tan inverse of 1, which is equal to 45 degree. Okay, so it means this angle is 45 degrees, right? So why I'm saying this, because this will help us find this length, which is OP, for example. Okay, I'm just giving this is OP here. Okay, this is P, right? So how much will be OP in that case? If this is 45 degrees, it means that this is also 45 degrees, right? Okay, and we know that this is 5. Okay, this is 5. We know this is 5. Okay, this is from this basis, right? From here to here, it is 5 here. Okay, so 1 second. I'll write properly here. Okay, so this is 5 here. Okay, so then what will be this? This will be 5 sine 45 degrees, right? So this will be 5 sine 45 degrees. This is equal to 5 by root 2. Okay, or we can also say this is 5 root 2 by 2. Fine. So now coming back to this equation, right? Angular momentum is equal to linear momentum into the distance. So what is angular momentum then? Linear momentum of mass into the velocity, right? What is mass? Mass is 6. What is the velocity? Velocity is given 5 root 2, right? 5 root 2. And what is the distance then in that case? This distance we have computed from the origin to this line, the straight line, right? There's a perpendicular line here. Okay, correct. So this line, what is the distance here? We got 5 root 2 by 2. 5 root 2 by 2. Okay. So if we just, so 3 into, so root 2 into root 2 is 2. 5 into 5 is 25. 25 into 2 is 50. So yeah, 150. So the answer is 150. Okay. So the answer is B. 1B. Okay. Let's go to the next problem now. A thin circular ring of mass m, right? So in this case, the mass of ring itself is m. Okay, the mass of ring itself, it is m. Mass is equal to m. Okay, I've not written here, so the mass of the ring is m. So in this case, there is no external force applied here, right? It is given that a thin circular ring of mass m, the originally this was the, and this is how rotating, right? This is how it is rotating here. Okay, fine. So this is a ring which is there. It is rotating here, right, in a horizontal plane. If I'm looking from the top line, it is like this. If I'm looking from the sideways, it is rotating like this here. Okay, right. It is rotating in a horizontal plane about an axis vertical to its plane. So this axis is vertical to its plane. So this is ring's plane. This is vertical to its plane. Okay, with a constant angular velocity of w. Okay, so the ring original or rather initial angular velocity is equal to w. Okay, so I can say that w1 initially. Okay, now so an initial mass, what is the initial mass? Mass equal to m. Okay, before attaching the two additional masses. Okay, the final, what is the final w? What is final w? We need to find. Okay, we need to find this final w. And what is the final mass? Mass is equal to m plus, there are two masses, each of 2m, right? So it will become 2 into 2m. So this becomes m plus 4m. Okay, so now since there is no external force applied on the system, so the angular momentum will be conserved. Okay, so what is the initial angular momentum? Initial angular momentum will be initial angular momentum. Okay, this is equal to, now this is a ring, right? So what is the angular momentum? What is the inertia of a ring? Mr square. Okay, mr square. This is the inertia into, what is omega? Omega is given here, omega, right? Now this has to be equal to the final angular momentum. What is final angular momentum? Again, I. What is the I for the body? M plus 4m into r square. Okay, so this is the I, right? I2, this is the I1, okay, into W here. And what is the angular momentum here? Into W. This is what I need to find, which is WF. Imagine WF here, okay? Then I need to find the value of WF. What is WF then? WF is equal to mr square into W divided by m plus 4m r square. Okay, so r square gets cut. So the answer is equal to W m upon plus m. Okay, so this is the answer, right? If you look at the first option, this is the answer here. Okay, let's go to the next problem now. In this question, it is given that a truck is moving on a road with a certain speed. Okay, so what is the speed here which is given to us? The speed is given to be 72 kilometers per hour. So imagine the truck is moving like this. Okay, imagine truck is moving like this here, and after some time the brakes are applied. After applying the brakes, obviously it will come to rest. Okay, so here, if this was initial velocity was w0, it will actually come and stop here with omega is equal to 0, because the wheel will stop moving after applying the brakes. Okay, what else is given to us? The moment of inertia of the wheel about its rotational axis is 4, right? So I is equal to 4 kg meter square. Okay, we need to know what is the torque transmitted by the brakes to the wheel if it is brought to rest in 20 seconds. So time is equal to 20 seconds in which it is brought to rest. And what is the initial speed is equal to 72 km/h. Now, since everything else is in meter, kilogram and second, we need to convert this to meters per second. So how do you convert this to meter per second? We will multiply this into 5 by 18. Okay, we multiply 5 by 18, so this becomes 4. This becomes 20 meters per second. Okay, this is the velocity here. So the velocity is given to me. What is so I need to find the original or initial angular velocity, right? What is the radius of the wheel is given to me is 0.8 here. Okay, so radius is equal to 0.8. We know that omega is equal to v by r. Okay, so v is equal to 20 and r is given to be 0.8. So this means that initial angular velocity is equal to 25. Okay, this is radians per second. Okay, so this is the initial angular speed. Okay, what is the final angular speed is equal to 0, because it comes to rest after applying the brakes for 20 seconds. Okay, so now what is the acceleration, or rather what is the retardation at after the brake, applying the brake? It is coming to rest after some time, right? So we need to know what is the retardation, right? So how do you find the retardation? We know that original formula, rotational motion formula, right? We know that omega is equal to omega 0 plus alpha t, right? Which is analogous to v is equal to u plus at. So here the final angular speed is actually 0. Okay, the original speed is actually 25, or rather the original angular velocity is 0. Alpha is negative, so I'm putting negative here. Alpha we need to find, and this is happening in 20 seconds. Okay, it means alpha is equal to 25 divided by 20. So this becomes equal to 1.25. Okay, I need to find that what is the torque, right? Torque is equal to I to alpha. The I is given to me is 4 kg meters per meter square. Okay, so this is equal to 4 into alpha is 1.25. So this is equal to 5. Okay, so torque is equal to 5. So answer here, so look at the answers given to us. The answer is B. Okay, let's go to the next problem now. A circular platform is mounted on a frictionless vertical axle. Okay, so he imagine that this is the circular platform. Okay, a radius is given to be 3 meters. A moment of inertia, the platform I can write I platform, which is equal to 150 kg meter square. Okay, it is initially at rest. Okay, initially at rest. A man being, now we have a man here. Okay, the man, his weight is equal to 60 kgs, right? He stands on the edge here. So imagine he comes here, right? He stands on the edge at this point, right? So now, if what will happen is that if he starts moving this way, then this platform will start moving this way in the opposite way, right? That's how will happen, correct? And eventually, this entire platform will start moving like this, right? This entire platform will start moving, right? So the man weighing 60 kg, man is weighing 60 kg, and he starts walking along the edge, right? So if he's walking on a platform, so because of friction, the platform will start moving this side, as we said earlier. So his speed v is equal to 1 meters per second, right? So that is the speed of this person which is given to us. Okay, the speed of the person is given to us is this thing, right? So what will be the, so we need to find that what is the time taken by the man to complete one revolution. So what will happen is that as it starts moving, so he is also starting moving this side, the man is moving this side, the platform is moving that side, and eventually what will happen is that the entire platform would have rotated, right? And the man will actually go around the entire platform, just walking around, right? That is what will happen. In this case, what is the man's average, what is the man's, and so here you look at it, right? So how will you target this problem? In this problem, we'll see that the angular momentum is conserved here, right? Angular momentum is conserved because there is no external force applied here, right? Angular momentum is conserved, right? So it means that whatever angular momentum we have for man, the same thing will be converted to the angular momentum of the platform. Okay, so let's see what is man's angular momentum. Angular momentum. So this is equal to linear momentum is m into v, and this is into r, right? Radius is r. Okay, there is radius of the platform. So what is the weight of the man? Is 60 kg. What is the velocity at which he's going? He's going at a velocity of 1, right? And what is the radius of the platform? Radius of the platform is 3. So this becomes equal to 180 is the angular momentum of the man. So if man's angular momentum is so much, so the platform's angular momentum will also be this only, right? The platform's angular momentum is equal to 180, right? Give me 180. Okay. Now we know that I1 W1 is equal to I2 W2, or rather should I put it like this? Platforms I into platform angular speed is equal to man's angular man's moment of inertia into man's angular speed, right? So that is what we need to find here. So here the platform, so here what is the speed at which the platform is rotating in that case? So WP is equal to IM we know, and IW also we know. This is the angular momentum of the man, right? So this is 180 here. 180, okay. The right side is the angular momentum of man. The left side is the angular momentum of the platform, right? Divided by IP. IP is given to be 150. This is equal to 1.2. Okay. It means the platform acquires an angular velocity of 1.2 radians per second, right? The radians per second. Now let's look at this, right? So the man is also moving at a angular velocity of 1.2 radians per second, and the platform is also going this way at 1.2 radians per second. Okay. So what will happen? What is the relative speed then? Now, if you recollect, right, if you recollect the straight line motion days, what we used to say is that imagine that there are two objects, right, who are approaching each other. See the object one, say for example, object one, O1, and object two. If this has a velocity of x and this has a velocity of y, right, and they are approaching like this, right, they are approaching each other, then what will be the relative velocity? It will be x plus y, right? And what will be the distance between them is this. So what I mean to say is that they will reach each other at much faster, right? Rather than only individual speed. So relative velocity in this case was x plus y. Okay, there's x plus y here. Okay, so in this case also they are moving in the opposite direction. Okay, since they are moving in the opposite direction, the relative velocity will get added up here. Okay, so relative velocity here, relative angular velocity is equal to 1.2 of man plus 1.2 of platform. This becomes 2.4 radians per second. Now let's look at this, right? So this has to cover the entire platform circumference, right? What is the platform circumference here? 2 pi. Okay, the platform circumference is nothing but 2 pi here. So this 2 pi has to be covered with this velocity, right? So the distance to be covered is 2 pi. So the time taken is equal to 2 pi is the distance to be covered divided by 2.4. This becomes pi divided by 1.2. Okay, so this is the answer. Okay, so time taken is equal to pi by 1.2. So if you look at the answers, this is the answer. Okay, let's go to the next problem now. In this question, it is given that there is a tube here, right, which is filled with a liquid of mass m. So imagine if this filled with liquid, there are so many particles of liquid here, right? In this, there are so many particles of liquid. So when this is made to rotate, when the tube is made to rotate like this, what will happen is that each of these particles will actually be looking, if you can see them individually, they are also rotating around this with a certain radius. So if you look at a particle here, for example, right, it is also rotating. It has a certain radius r, okay, and it has certain mass, okay, and obviously this will be the v here, okay. Similarly, if a particle is here, then similarly this will have a certain radius of rotation, okay, and this will have a certain mass. So why I'm saying this, because we cannot just apply a formula here that, okay, why don't we apply a simple formula for the centripetal force which will give me the force applied at the tube's end. Okay, why we cannot apply? Because there are various masses, each of them having a different radius of rotation around the center. Okay, so that is why we have to apply here integral calculus here. Okay, so in that case, so let's make it a, let's clear this up here. Okay, so in that case, let's look at a small cross section, say dx here. Okay, so imagine this is dx. Imagine that this is dx. Okay, and this is rotating like this, right? The tube is rotating like this. To be rotating like this. So for length L, for length L, for length L, mass is equal to m. Okay, so for unit length, mass is equal to m by L. Okay, then what is the for length dx? If you take a small length dx, right, then mass is equal to m by L into dx. Okay, so this is dx here, right? And imagine that this is x. This is x, right? From here to here, this is x here. So What will be the centripetal force on this particular cross section of dx then in that case? So centripetal force is equal to, say in this case it is centripetal force is equal to m. This is general formula, right? Is equal to m r omega square. Okay, so now what is the mass of this small part? It is m by l into dx. Okay, what is the radius for rotation for this particular dx rotating here? What is the radius is x. Okay, into omega square. Okay, so now force is equal to, we have m by l to omega square x dx. Okay, this is the force because of this, right? So the total force will be the integral of this from x is equal to 0. X equal to 0 is at this point for all the particles which are from x equal to 0 to x is equal to l. Okay, so this will be the total force. How do you calculate this? M by L W square, sorry, m by L W square into what is x dx. If I integrate this, right, this becomes x square by 2. Okay, so this actually the value of x is equal to 0 to x is equal to L. So this is equal to m by L W square into, if you put L here, it becomes L square by 2, right? It becomes L square by 2 minus of minus. So if you put 0 here, this becomes, entire thing becomes 0, right? So this becomes minus 0. Okay, so this becomes equal to m by L W square into L square by 2. So L gets cancelled here. This remains m L W square by 2, right? So this is the answer. If you look at the options given to us, C is the answer. Okay, let's now move to the next problem. In this problem, it is given that there is a triangular plate which is rotating around 3 axes, right? Which is made to rotate around 3 axes, and we need to figure out that which of them is the highest here. Okay, so let's take, so this is a triangular plate, right? Now before that, before we do that, we need to know what is the moment of inertia of a triangular plate. So we need to know this formula, moment of inertia of triangular plate. So moment of inertia of triangular plate is equal to m L square by 6. Okay, where m is the mass of the body. Okay, right? So now okay, so now let's see what will be the, now as we know earlier, right, the moment of inertia also depends on the axis of rotation. Okay, so imagine that if this is the axis of rotation, this is made to rotate around this axis, right? Made to rotate around this axis. Okay, so in this case, the I, so I'll say I of AB. Okay, I of AB means it is rotating around AB as an axis. Okay, this m by 6 into L. What is L here? L will be the farthest point here, right? So this will be 3, correct? So there will be 3 square. Okay, so this becomes equal to m by 6 into 9, right? Now what about BC then, right? If it rotates around, now, so we found out this part of it, right? Now what if it rotates around BC, right? If it rotates around BC, right? Okay, rotates around BC, then I of BC is equal to m by 6 into, what is the farthest point, the vertex here? This is 4, right? So this will be 4 square. Okay, so this will be m by 6 into 16. Now what about IAC? IAC is equal to m by 6 into, now what is this distance here? We need to know this distance, right? Otherwise you cannot compute it. We need to know this distance, right? So how to calculate this distance? Now this is a right angle triangle, correct? So right angle triangle, the area will be the same, however way you calculate it, right? So if you take this is the base, this is the height, the hypotenuse, what is the area of a right angle triangle? Area is equal to half into base is 3 into height, okay? Now similarly, if you now take this as the height, which is BD as the height and AC as the base, then the area should be the same. Then in that case it will become half into BD into the base is 5, right? So this has to be the same, correct? So I'll say then half into 3 into 4 is equal to half into BD into 5. Why you're doing all this? Because we need to find BD, right? To calculate the rotation, to calculate the moment of inertia when this is made to rotate around AC, okay? So we cut this here, so it means BD is equal to 3 into 4 is 12, 12 by 5 is equal to 2.4, okay? 5 is 2.4, right? So m by 6, so IAC is equal to m by 6 into this particular height, now we computed is 2.4, okay? So this will be 2.4 square, because we need to take the distance from the base to the vertex, which is 2.4 square, okay? So this is equal to m by 6 into 5.76, okay? If you compare the three values, you'll see that the maximum is IBC, right? So this is the highest here, okay? So before you, now we go to the question answers here, options given to us. So IBC is certainly the highest. Now what is this option? IAB plus IBC is equal to ICA. Now we need to understand this also. If you remember in the concept, we talked about the perpendicular axis theorem. So what is perpendicular axis theorem means that the perpendicular axis theorem states that if, for example, if you have three axes here, right, which are perpendicular to each other, this is IZ, which is in Z direction. This is IX, which is in the X direction. And if this is IY, which is in the Y direction. So it states that IY is equal to IX plus IZ, okay? So all these three are actually perpendicular to each other, okay? All these three are perpendicular to each other, right? All these three are perpendicular to each other, and IY is perpendicular to both IX and IZ, okay? If you look back at the options we are given to us, then in this case, IAB, IBC and ICA, there are three moment of inertia is given to us, but ICA is not perpendicular to both IBC and IAB, right? So this option is incorrect, okay? The only option which is applicable is this one, okay? So this is the answer. Now we move to the next question now. What is the moment of inertia of a uniform circular disc of radius r and mass m about the diameter of the disc, okay? So in this case, we know that we have a formula. We just now went through that, right? It's a perpendicular axis theorem. It says that IY is equal to IX plus IZ, okay? Where all the three are perpendicular to each other, okay? And IY has to be perpendicular to both this one as well as this one, right? So now this is a uniform circular disc, right? For uniform circular disc, we know that what is IY, right? When, so if this is the disc here, this is a disc which you can see here, right? If it is rotating like this, correct? This is a disc here which is rotating like this here, right? And the axis is passing right through it, and it is perpendicular to the disc. Then in this case, we know that it's equal to M r square by 2. Okay, it means Iy is equal to m r square by 2. So this is equal to Ix plus Iz, right? Ix plus Iz. Okay. Now, why we are even worried about Ix, Is, because we need to find. The question is that what is the moment of inertia about the diameter of the disk? So what is diameter of this? The diameter of disk could be either Iz you can find out here, or we can even find out Ix also, right? And given the symmetry of the disk, right? Because disk is symmetrically uniform, Ix is actually going to be equal to Iz, right? Iz is equal to Ix. So if you just put it Iz, Ix, so I imagine, so this is equal to Ix. I can say that Iz is also Ix, right? So I can put Ix. Okay. So it means I can say that 2Ix is equal to mr square by 2. It means Ix is equal to mr square by 4. What is the Ix or Iz? This is the moment of inertia about the diameter of this plate, right, of this disk. The answer is equal to mr square by 4. If you look at the options given to us, the option is A. Okay. So friends, if you are liking this video and if you are learning something from this, we request you to please like and subscribe to this channel so that we get motivated to prepare more such content like this. So in this video, we have solved the first 7 questions of this particular video. In the next session, we will undertake the rest 5 questions. Okay. If you have any questions, please let us know in the comments and we'll be more than happy to answer to them. Okay. Thank you.